This video is going to cover careers and jobs you can get in computer engineering. In my other video on computer engineering, I talked mostly about the curriculum, so let's get into what you can do after college. Now note that computer engineering is pretty much the combination of computer science and electrical engineering. So as you're watching this, you may ask whether an electrical engineer or maybe a computer scientist could also do that job, and the answer will very often be yes for at least one of them. It's rarely some black and white answer of only computer engineers can do this and only computer scientists can do this. They have their differences, which I discussed in another video, but hopefully this just gives you an idea of what you can expect. So let's get into it. Now, many jobs you can get into include software developer, computer systems engineer, network systems administrator, and a few others, all of which I talk about in the computer science careers video that I'll link below so I don't repeat everything. So again, there is overlap. But of the many subfields of computer engineering, the first I'll talk about is computer vision. This is really big in robotics, but that's not the only option. Computer vision is basically about making a computer understand visual data. Like instead of a sensor that can just detect that an object is near, computer vision would be like a computer recognizing a person in a picture versus an animal, and it would do this with high precision. But computer vision can also be broken down into more subcategories like image restoration, or taking a corrupted or noisy photo and being able to estimate the original. Or there's motion estimation, where basically given a sequence of images, a computer would determine what moved and how it moved. This could help in gesture recognition, it could help for lip reading if you have no audio, which could maybe help for security purposes, or it could help in robotic surgery like analyzing heart movements during heart surgery. But going back to computer vision in general, you could apply this to detecting events like counting how many people walk into a store. It can help in navigating a robot or a self-driving car. It can apply to inspecting products like in manufacturing to see if they are properly made. Or it can apply to medical applications like recognizing an abnormality such as a tumor in a medical image. Looking up jobs in computer vision, the first two that actually came up were at Snapchat as a research engineer, where you'd use knowledge of 3D reconstruction, image tracking, matching, multi-camera computer vision systems, and more to develop computer vision systems for the application. There was one listing at a virtual reality company where you design computer vision software and develop real-time 3D scene reconstruction while implementing algorithms for object detection and recognition. And note, these were research jobs, so they did require masters or even PhDs in order to enter into that specific job. Moving on to another field is computer networks. Computer networks are basically a way to allow computers to share resources. Basically, when two devices can exchange information, they are networked together. This could be like connecting to the World Wide Web, computers connected to a printer, or even a fax machine, and so on. There are lots of applications to this. How the network is laid out, dealing with network traffic, how they transfer data like through wires or wirelessly like with Wi-Fi, are all important. In fact, as a quick side tangent, computer scientists learn an algorithm called Dijkstra's algorithm that I talked about before, which helps determine the shortest path from one point to another, which could apply to something like Google Maps. But one of the most well-known applications of this is applying it to computer networks and optimizing their connections and how information is transferred. And networks comprise of a lot of things, but some that you may know include a modem or a router. You can get jobs in designing the hardware for these. You can get into network security and making sure hackers can't get into the network. You can be a computer network architect where you have to basically design the data communication networks, such as local area networks where the computers are more closely linked, like within one building or a few adjacent buildings. Then there's wide area networks, which is where the computers are further apart, and intranets, which are private networks only accessible to an organization's employees. Honestly, there are a lot of jobs you can get into in this field. Next, another subfield is embedded systems, which is also a very broad field. Embedded systems are basically a computer system which performs a certain function within a larger mechanical or electrical system, hence it is embedded in the larger system. This can include MP3 players, small radios, washing machines, traffic lights, avionics, rockets, and more. Here's the interior of a certain modem, and you can see there's many components to it. There's a microprocessor, the flash memory, and much more. And this is an embedded system that is part of the entire modem/router system. So you can work in designing these components and making sure the embedded system works properly within the larger system it's a part of. One job listing I found was as an embedded systems engineer, which was for recent college graduates, which included PCB or printed circuit board design and testing for whatever projects they are working on, ranging from analog sensor interfaces to high frequency devices for communications. Two other fields you can get into, which I'll just talk about as one, are compilers and operating systems. Compilers are what convert computer code in some programming language into machine code that can be read by a computer. So like when you type printf hello world, it prints hello world to the screen. But how does the computer actually know what to do? Because computers can't actually read this. They don't read most of the languages that you will be programming in. They can only read machine code, whereas this is called source code. So a compiler, which is just a program, takes that code that a person can read and converts it to a language that the computer can read and execute. Looking up job listings, there's one at Google where you'd work on a lot of the aspects of Google Chrome, from compiler optimization to security features. Or there's one for an artificial intelligence research company where you'd help create compilers for systems tailored for big data processing. These are mostly software engineering roles because compilers are simply programs you'd be writing rather than working with hardware. Then operating systems can get quite complicated. They are what manage computer hardware and software resources and provide services for computer programs. Pretty much all computer programs require an operating system. Cell phones, video game consoles, as well as supercomputers all include operating systems, just to name a few examples on top of a normal desktop computer. Common operating systems you've probably heard of are Windows for desktop, or iOS and Android, which are both mobile operating systems. And engineers are needed to make these and keep updating them. Remember, these jobs will be mostly in software rather than working with hardware, because you can update your computer to Windows 10 or update your iOS on your iPhone without physically having to replace parts. It's all computer code that engineers had to work on. And you can take classes in college dedicated to compilers and operating systems, so there's way more to them than what you've seen here. Then another field is signal processing, which is common for electrical engineers as well, but you absolutely could get into the field as a computer engineer. Signal processing is about the analysis and modification of signals, which are basically functions that convey some kind of information like speech, text, video, temperature, force, etc. For example, this is a signal that looks really messy. No one can really tell you anything special about this. But using signal processing techniques, you can get a plot like this that shows it actually contains a very specific frequency. So you could see maybe someone has a device operating at that very specific frequency. Or if you wanted to make a signal jammer to block this signal, this technique can help you determine what frequencies are coming from a device. This has so many applications, so there's no way to include everything, but it can be used for speech processing, like determining what someone says by the signal from a microphone. It can be used in image processing, like unblurring an image, or using filtering techniques to determine brightness changes and more to get more detail. These images you see here are a result of different filtering techniques to achieve the image here. This is the end result where all the other pictures are where you'd start out. There's seismology and detection of earthquakes, video processing, control systems, and even compression or reducing the amount of bits while not losing information, and much more. There are jobs listed at a company developing audio equipment to optimize the quality through signal processing. You can work on signal processing for military GPS receivers, which have to be very accurate. And actually, I knew of someone who worked at a defense company, and their job was to interpret signals coming from certain aircrafts, and they had to determine where the signals were coming from and if they are coming from an enemy or a safe source. And by the way, this is a very math-intensive field. As a computer or electrical engineer, you will take at least one signals class in college, and of all your major courses, that one will be one of the most math-intensive. And real quick, there's also integrated circuits where you'd improve speed, efficiency, and reliability of the circuits that are used in things like our computers and phones. But these can apply to audio amplifiers, video processors, memory, and more. Remember, computers have over 1 billion transistors to make them work, and the faster those all work, the better. And I'm going to stop there, but as always with these videos, there's of course more you can do. But also know for many majors, it's fairly easy to explain what you could work on, like building a bridge or designing an engine to be more efficient. This is something we can all understand. But with computers, there's so much more that most people don't have any idea about. Like compilers was one that most people probably don't know exist, even though they are in so many things we use. But as some examples, you can get jobs working in parallel computing, which is basically computation where large amounts of calculations are carried out simultaneously, such as this picture where you can see a supercomputer here at IBM. Or there's computer architecture, which describes the functionality and organization of computer systems, which has many aspects to it, like an arithmetic logic unit, or a MUX, which aren't something most people know about. So you see there's much more within our computers and other systems that you just have to learn more about if you go into this field. And lastly, on a very high level, computer engineering can be simply broken up into computer hardware engineering and computer software engineering, where one side is more related to electrical engineering, like with circuits, microprocessors, routers, and so on, although there are some differences, and the other is more related to software engineering or computer science. And some schools may focus more on one than the other, where you're exposed more to hardware or software classes. But overall, I hope this gave you a good idea of what you can get into as a computer engineer, and if you liked the video, don't forget to comment, like, and subscribe, and I'll see you all next time.